Hello, my wonderful students, and welcome back. It's so good to see all of you again. I know. Exams are just around the corner, breathing down our necks. So today we're going to crack a chapter that looks really tough, but trust me, with the right tricks, it's super easy. If you're finding these explainers helpful for your prep, please do hit that subscribe button, and don't forget to tell me in the comments which chapter is giving you nightmares next. Okay, let's jump right in.
All right, let's start with a little challenge. Have a look at this. Can you calculate 98 to the power of 5 in just 30 seconds? I mean, just imagine doing 98 times 98 times 98 5 times. Oof, what a headache, no? You'll be sweating bullets and you'll run out of time in the exam hall for sure.
So you might be asking, why are we even bothering with this chapter? Well, because the binomial theorem is like a superpower. It's a fantastic shortcut, a master key, that turns these ridiculously long, painful problems into something you can solve in a flash. This is a true exam-winning tool, my friends. Now, to understand this big theorem, we're not going to start with some scary, complicated formula. No. We are going to start with something you're already a master of. Let's become detectives and uncover some simple, hidden patterns together.
Do these look familiar? Of course they do. You've been seeing these formulas since, what, your junior classes? A plus b squared, a plus b cubed. You probably know these by heart. See? This is our starting point. Nothing new, nothing scary at all.
Okay, now here's where it gets really interesting. There's a super simple pattern hiding right here. In any of these expansions, just notice how the power of the first term, a, keeps decreasing. It goes down, down, down. And at the very same time, the power of b keeps increasing. It goes up, up, up. And here's the real magic. If you add up the powers in any single term, they always equal the main power, the index. How simple is that? Okay, so we figured out what happens to the powers of a and b. That's sorted. But what about those numbers in the front? You know, the coefficients, like that 1331? Well, for that we have our very first amazing trick.
So this beautiful pattern of numbers is called Pascal's triangle. But did you know that long before Pascal, our very own ancient Indian mathematician Pingala described this in his book as Meru Prastara? How cool is that? It's our own awesome trick, straight from ancient India.
And building this thing is like a fun little game. Every new row starts and ends with a 1, always. And to get the numbers in the middle, you just add the two numbers that are directly above it. See on the slide here? 1 plus 3 gives you 4, 3 plus 3 gives you 6, and 3 plus 1 gives you 4 again. See? You can create the next row in literally seconds. Now, this is great for small powers, like 4 or 5. But what if your exam question asks for power 15? Or what if it's power 50? Are you really going to sit there and draw 50 rows of this triangle? Of course not. That's just crazy. We need a faster, more powerful tool for the job.
Okay, it's time to upgrade. We're moving from the simple trick to the professional tool. For any power, whether it's big or small, the real secret to finding these coefficients lies in combinations. Remember NCR from your permutations and combinations chapter? Yep, that's our key.
And here it is, the big secret. Each and every number in Pascal's triangle is really just a combination value. Just look at the row for n equals 4. The numbers 1, 4, 6, 4, 1 are actually just 4C0, 4C1, 4C2, 4C3, and 4C4. This is the master key. This changes everything. Now you don't need to draw that triangle ever again. You can find any coefficient you want directly.
So, we have all the pieces of the puzzle now. We have the pattern for the powers of a and b, and we have the NCR trick for the coefficients. Let's put it all together and reveal the one formula to rule them all, the binomial theorem.
And there you have it. I know, it looks a bit long, but please don't be scared. It's just the 3 simple patterns we already discussed all put together. Part 1, the coefficients are just NC0, NC1, NC2, and so on. Part 2, the power of a starts high at n and just goes down by 1 each time. And part 3, the power of b starts at 0 and goes up by 1 each time. That's it. That is the entire theorem. Simple, right?
Okay, enough of the theory. The real fun in maths is actually solving problems. So let's take our new master key and use it to crack some actual exam-style questions. Are you ready for this? Let's do it.
Let's go all the way back to our very first challenge, that scary-looking 98 to the 5th,
Well, now, with our new tool, this thing is going to be a piece of cake. Let me show you how.
So the first trick here is to rewrite 98 as something easier, like 100 minus 2. Now it's so simple. Our a is 100, our b is -2, and our n is 5. We just plug these values into the formula we just learned, term by term. After some simple calculations, you get the final answer. 90 crore, 39 lakh, 20,798. Wait, my notes say 68. Let me check. Ah, yes. 93,000, 20,000, 79, 68. See? No painful multiplication at all.
Okay, now for a question that looks completely impossible. 1.01 to the power of 10 lakh versus 10,000. Which one is bigger? You can't possibly calculate that first number, right? But with the binomial theorem, you don't have to.
Let's use our brain here, not just a calculator. We can write 1.01 as 1 plus 0.01. Now let's just expand the first two terms using our theorem. The first term is always 1. The second term is 10 lakh times 0.01, which is 10,000. So just the first two terms give us 1 plus 10,000. And then there are a whole lot of other positive terms after that. So it's obviously, clearly, much, much larger than 10,000. And just like that, problem solved in 2 simple steps.
And that's a wrap on the binomial theorem. Remember, my dear friends, maths is never supposed to be hard. It's a game, and you just need to learn the rules and the special tricks. Today, you've added one of the most powerful tools to your arsenal for your exams. Now, the most important step is for you to go and practice. All the very best. I will see you in the next explainer.